China's still also a poor country by world standards, but they were more far-sighted, and they knew a PhD would take them further, especially in money terms, than having only a master's degree. In fact, I read somewhere, someone did some statistics that a person with a PhD in America, on average, has a salary over their lifetime almost double of somebody who has a master's degree. So it literally pays to get a PhD. So if you're thinking of getting one and you're smart enough, go for it, because you will be better off financially. Okay. If this is the first time, like if this is the first course you've taken with me, you may not be aware. I tend to mix politics, my personal views, and the technical stuff quite freely. You probably wouldn't be able to do that in university, but as I say, I'm a free prof, right? I'm providing material so students, so you guys can teach yourselves for free. But I'm also free in the sense I can say what I like, right? I'm free. Okay. Okay, so Z, capital Z, or Z. That's the symbol, very commonly used in mathematics. It's the set of integers, right? Whole numbers. And written out in set terms, set in terms of set notation. So wiggly brackets, 0 plus or minus 1 plus or minus 2. Separated by commas, dot dot dot. Okay, so that's the set theory way of writing out Z, the set of integers. God knows why it wasn't written I. N makes sense, natural numbers, right? Oh, yes, now I understand. I should tell you, I lived in Europe, continental Europe, quite a long time. So I picked up quite a few continental European languages. So I'm fairly fluent in German, speak German, quite fluent in French, because my second wife was French speaking. I did 15 years in Brussels, which was largely French speaking. So French is almost as unconscious as English. So I speak French, German, and Dutch, because Brussels was bilingual, French and Dutch. So my Dutch is pretty well, also almost as unconscious as French, but I had more use in French. So I know German, okay? I can Deutsch sprechen, I can speak German. And the German word for number is Zahl, Z-A-H-L. So that's where the Z came from. It's German, okay? And it just means integer, the whole numbers. But you know, including 0 and the negative integers. So all integers, it's just Z, okay? Now, there's another symbol here, commonly used in set theory. It's just capital 0, I guess, you know, with a stroke through it. And that symbol, in the context of set theory, is reserved to mean the set without any members. In other words, the empty set. Right? So it's just wiggly brackets and nothing between them. Okay. So that's referred to as the empty set. Now, so we've been talking about one way of writing down a set, and that is just simply to list a complete list of its elements, its members. That's one way. Now there's another way of writing down a set, and that is you give a symbol like here, like set of elements n. And then this vertical bar here, read that as such that. And what does that mean? It means having the property, or properties of, right? Or having the following property. So you list the elements or members of your set according to some rule or property of belonging. So if some thing matches the rule, you know, obeys the rule, then it's a member of that set. Okay? I'll give you some examples. Say you wanted to write down the set of all squared integers. You know, the set of all integers squared. So you write down, it's a set of all these numbers. Oh, wait a minute. No, sorry, take what I said. Well, to be consistent with the board. So you're writing down the set of numbers that are perfect squares, like 1, 4, 9, 16, 25, 36, 49, dot, dot, dot. Okay? So they're the set of numbers n such that, or have the property that n is equal to some integer squared. Right? So, well, it's the same thing effectively. n belongs to the natural numbers, to here. But it would be the same thing if you put a z, because repetitions get thrown out, remember. Is that quite the same? Z also has a 0. No, not quite, except for the 0, right? Okay, so, but yes, detail. So this is an alternative way to write out a set. So you have one symbol representing the elements of the set, a slash, a vertical bar, if you like, and then a property or properties that this element here has to satisfy, some kind of rule, inclusion rule, membership rule, and in this case, this n has to be equal to the square of some natural number, right? So you'll have some membership condition on the right hand side here, and on the left hand side, relative to this bar, you just have some symbol that symbolizes the members of your set. Okay, so one way you just write out the complete list, you just write out all the elements. That's not practical when the list is large. Okay, so in practice you tend to use this one, where you use some rule of inclusion, rule of membership, some property that the members of the set have to obey. Okay? So this is like the second main way of writing out a set. Okay, the union, what's that? So these two terms related. So the union and intersection of two sets. It's a connection between two sets. So so the union of two sets. So A and B, and you write it this way. So it looks like a U. So I guess U for union. So you got A union B. And what does that mean? Well, it's a sort of a bigger set, and it consists of all the elements of A plus the elements of B. Okay? That's the definition. So it's a set of elements that belong to A or B. That's an alternative way of saying the same thing. Right? So say I had two sets of marbles, and I had a hat here, and I took all the marbles from set A and put them into the hat, and all the marbles from set B and put them into the same hat. Then the set of marbles in the hat is the union of A and B. Right? It's just you put the elements of A together with the elements of B in one set. Right? That's the union. You've combined them. You've unionized them, if you like. Right? So the union of two sets is just now here's the description notation, like similar to here. You've got it here, right? So it's these are your elements X belong to this set, such that, right, X belongs to A or X belongs to B. Right? It's the elements of both. You take the elements of A and you combine them with the elements of B. You just put them together in the same set. Right? So that's the union. Now the intersection, that's the subset of elements that are in both A and B. It's the elements in the two sets in common. Now how do you write it? Now this is the union, and the intersection is the other way around. So it's sort of this symbol reversed this way. So it's sort of looks a bit like a it's like an upside down U, if you like. There's your U union. So this is This is the symbol for intersection. So A intersection B. Now it's the set of elements that belong to A and B. Right? So it'll be in general it's a smaller set. Okay. Now I don't know if you can see this, the first line of the next session. So it's a set of elements that belong to A and belong to B. Right? So you can write it. I hope this comes out. So A intersection B is defined as the set X such that X belongs to A and X belongs to B. Right? So the intersection is the set of those elements that belong to both the sets. Right? Well, next I'll stop there because I need to change the camera angle, and we'll do the next session, and we will do complement. It's all in context of set theory. We'll do complements, Venn diagrams, and then we'll move away from sets and start talking about sequences and tuples, T-U-P-L-E-S.